Now let us start with some problems where two diodes are used instead of a single diode. See this first question. Assuming that the diodes in the given circuit are ideal, the voltage we output is. It was a question asked in GATE 2004 electrical engineering. Okay, anyway, they have mentioned the diodes are ideal. Okay, how do we do this problem? If you let me assume this as diode D1 and this is diode D2, then look at the anode of D1. It is going to positive terminal of the 10 volts source and its cathode is going towards negative terminal of 10 volts. Okay, it looks like D1 is conducting. And if you look at D2, the diode, its anode is going to the negative terminal of 15 volts and its cathode is going towards the positive terminal of 15 volts, or you can take its cathode is going towards the positive terminal of 10 volts, right? Anyway, it is connected to both, it looks like. So definitely D2 is off. So what we can take is just by inspection, by observation, we can say D1 is on and D2 is off. If that is the case, D1 acts as short circuit and D2 acts as open circuit. What will be our equivalent circuit? And it is mentioned this is Vout. Okay. Now if you observe this, a very basic simple network. So the entire current flows through D1 and to 10 kilo ohm resistors. So what is the output voltage division rule? We can take V output is equal to 10 volts by 10 kilo ohm plus 10 kilo ohm into 10 kilo ohm. It is equal to 5 volts. So if you look at the four options, option B is correct. A very simple question it is. Okay, further out interest, right? Further, if you want to analyze, you look at these things. As D1 is on, it acts as short circuit and the voltage here will be 10 volts. In that way also you can see, then cathode of D2 is going towards 10 volts and its anode is going towards minus 15 volts. So there is no scope for D2 to conduct at all. So D2 does not conduct. A very simple question it is. Okay, next. See this. Assuming that the diodes are ideal in figure, the current in D1 is, what is the current through the diode D1? Okay, say this. If you observe D1, its anode is going to positive terminal of 5 volts supply and its cathode is going to negative terminal of 5 volts supply. It looks like D1 is on. Next, what about D2? Its anode is going to positive terminal of 5 volts and the cathode of D2 is going to minus 8 volts. So anode is looking like at higher voltage compared to cathode as far as D1 and D2 are concerned. So I can assume that both D1 and D2 are conducting. Assume D1 and D2 are on. We can take. So D1 and D2 act as short circuit. So that what is our equivalent circuit? This is how we can write the equivalent circuit. Let me assume this voltage as Vx. Okay, they are asking us to find the current through D1. Means this current I can write ID1 and this current as ID2. So what we can find here, ID2 directly we can find. Okay, what about Vx? It will be 0 because D1 is acting as short circuit. So ID2 is equal to 0 minus of minus 8 by 1 kilo ohm. It is equal to 8 milliamperes. Next, ID1 we can't find it directly. So let me assume this current as I. So I is equal to 5 minus 0 by 1 kilo ohm. It is equal to 5 milliampere. Okay, that's it. Then what about ID1? It looks like I is equal to ID1 plus ID2. So ID1 is equal to I minus ID2. I is less than ID2. Is it possible to get 8 milliamperes of current from 5 milliamperes? No. Right, 5 volts is our source, right, from which the current coming is 5 milliampere. Then how can you have ID2 to be equal to 8 milliampere? It is not possible. Or if you observe ID1, it is found to be negative 5 minus 8 minus 3 milliampere. It is not possible because if D1 conducts, the current from anode to cathode of D1 should be positive. When does the diode conduct? When its anode is at higher voltage compared to cathode, then only diode conducts. If that is the case, anode to cathode current also should be positive. It is like higher potential to lower potential, the current is flowing. But higher to lower potential, the current is found to be negative. It is not possible, means our assumption of D1 in conduction is wrong. ID2 is coming positive, there is nothing to worry about it. So definitely D1 does not conduct. Once D1 is not conducting, D1 acts as open circuit. Anyway, the current in D1 is simply 0. ID1 is equal to 0 milliamperes. So option C is correct. Okay, this is where our problem is over. But friends, don't look at the answer only. We are practicing, we are learning the concepts. Always you try to extract something more beyond what you have done. Okay, the problem is given, we have done the answer. Okay, it's over. Don't throw it. Don't close it. Try to right do something beyond what is given. Okay, why D1 is off? It looks like its anode is going to 5 volts, positive terminal, anode is going to positive terminal of 5 volts and the cathode is going to negative terminal of 5. But how the diode D1 is off? Let us try to do some post-mortem of this particular question. Okay, Vx, I have written 0 volts. Is it really 0? That's true if the diode D1 is on. As the D1 is not conducting, Vx may not be 0. Okay, so that what is Vx and what about ID2? Let us find those two things. My equivalent circuit will be something like this. As D1 is acting as open circuit. 5 volts, 8 volts, 1 kilo ohm and 1 kilo. And how does the entire current flow? 5 to minus 8 volts, and this current is ID2, and this voltage is Vx. Then what about ID2? If I take so, it is 5 minus of minus 8 by 1 kilo ohm plus 1 kilo ohm. Here it is 5, here it is minus 8, 5 minus of minus 8 by 2k. So 13 by 2, 6.5 milliampere. This is the actual value of ID2. ID2 cannot be 8 milliampere. ID2 is less than that. Okay, 8.5 milliampere. ID1 is 0. Then what about Vx? If I take Vx, it is equal to ID2 into 1K minus 8 volts. Voltage at this point with respect to ground. Or 5 minus 1K into ID2. Anything we can write. So it is a 6.5 milli and kilo cancel minus 8. It is equal to minus 1.5. So Vx here is not equal to 0. Vx is not equal to 0. Or if you observe this, the anode of D1 is at minus 1.5 volt and its cathode is at 0. Anode is at a lesser voltage compared to cathode, and hence the diode D1 is not conducting. This is the interesting point you can see. Okay. So why all such things are taking place means this is the additional part which is influencing our diode D1. So the moment you see the circuit, we cannot simply conclude that D1 is on. Okay. We don't know how the other parts of the circuit are influencing the diode D1. We should be very careful in observation. Okay, this is the additional information. Once right, not only analog circuits, any subject you take, it is don't be in a hurry to solve the problems one by one immediately. Once you solve the problem, at the end, what are the other things possible from the given problem? Because for creating one problem, the professors break their head like anything. So that is our best example for analyzing the concepts and creating few more questions throughout. You can see that. Okay, next question. See the same question, I changed the resistor here. Instead of 1 kilo ohm, I have taken here 2k, but the procedure is same. The circuit is not changing except the resistor values. Then how do we do this problem? Again, the same procedure. If you look at D1, its anode is at a higher potential, right? Its anode is going to positive terminal of 5 volts, and its cathode is going to the negative terminal of 5 volts. And at D2, its anode is going towards a positive terminal of 5 volts, and its cathode is going towards the negative terminal of 8 volts. So, as usual, it looks like both D1 and D2 are conducting. Assume D1 and D2 are on. It looks like both are conducting. So that what is the equivalent circuit? This current is ID1, this current is ID2, and this is I, let me assume, and this is Vx. It looks like Vx is 0. Then first what we can calculate? ID2. ID2 is equal to 0 minus of minus 8 by 2 kilo ohm. it is equal to 2, sorry, 4 milliampere. Next, we can calculate I. I is equal to 5 minus 0 by 1 kilo ohm. It is equal to 5 milliampere. Yes, I is equal to ID1 plus ID2. So ID1 positive, ID2 positive, and ID1 plus ID2 is looking like greater than ID2. No doubt about it. Or ID1 is equal to I minus ID2, which is equal to 5 minus 4, 1 milliampere. That's it. The circuit is not changing. Only thing is just I changed one resistor value. Instead of taking 1K and 1K, I wrote here 1K and 2 kilo ohm. So anything is possible, but the point of observation here is our procedure is not changing. I'm not changing the procedure from problem to problem. Right? Once I develop a procedure, means 99% of the problems can be done with that procedure. You can observe that. Okay. So previous problem or this one, the procedure has not changed. It looks like D1 and D2 are conducting. With that, what is a possible circuit from which I try to calculate ID1 and ID2. Okay, in which ID2 has come as positive and ID1 is also positive. Sorry, ID1 and ID2 are positive, so no issues. There is nothing to worry about it. Whereas in the previous one, ID1 is found to be negative, which is not possible. Means D1 is off. That's what we did.